Conditional probability. Assume that two fair dice are rolled. First compute the probability of F and then probability of F given E. Explain why one would expect the probability of F to change as it did when we added the condition that E had occurred. First, we want to find the probability of F. We're told that F is the event that the total that appears on the two die is 5. So I'm just going to write this as the probability of 5. And again, we're dealing with two dice. So I'll draw a little chart here. I'll label these columns as 1 through 6 to represent the 6 sides of the die. And then the rows will be 1 through 6 as well to represent the 6 sides of the second die. Now I'm dealing with totals, so I'm just going to add the row and the column together to get the sum. And so all my sums will be inside the chart. So my first sum is 1 plus 1, which is 2. My second sum is 1 plus 2, which is 3. And then 1 plus 3, which is 4. And then I'll have 5, 6, and 7. And we'll continue this for each sum in the chart. And I should have 36 sums in all. Okay, so I listed all of my sums. Now I want to find the probability of getting a total of 5. So I'm just going to circle all the 5s in my chart. I have 1, 2, 3, 4. So the numerator of my probability is the number of times that 5 occurs, and that would be 4 times. And then the denominator is the total number of outcomes. And there are 36 possible outcomes. Now I want to list this fraction in simplest form. So 4 and 36 are both divisible by 4. So when we divide the top and bottom by 4, I get 1 over 9. So my probability of F is 1/9. That's my first answer to this problem. Now I want to find the probability of F given E. This is a conditional probability because I want to find the probability that the total is 5 given a condition. In other words, the condition is saying that this event E has already occurred. The formula for a conditional probability of F given E is the number of times the intersection of the two events occur divided by the number of times the second event occurs, or E. First, we want to find the denominator, which is the number of times that the event E occurs. So if we look at this, E is that an odd total is showing. So we want to count the number of times that an odd total can show. If we look at our chart, we can see all of our possible outcomes. And I'm going to highlight the odd outcomes. So we have the 3, the 5, the 7, the 3, the 5, the 7, then the 5, the 7, and the 9, again the 5, the 7, and the 9, and then the 7, the 9, 11, and the 7, 9, and 11. So if I count the number of sums that I just highlighted, we have 18 possible odd totals. So the denominator of my conditional probability is 18. Now I want to find the numerator, and the numerator is the number of times that those two events intersect. So that means that both events occur at the same time. So the event F is the total of 5 shows, and the event E is that an odd total shows. So we're going to look at all of the sums that we highlighted green on the screen. So now from those highlighted sums, we want to pick out the numbers that have a total of 5. Because again, we're trying to figure out the number of sums that are 5 and odd. So if we look, we have 1, 2, 3, 4. 4 times that a 5 occurs amongst those odd totals. So my numerator is 4. And my conditional probability of P of F given E is just 4 over 18. And again, I want to simplify that fraction by dividing both the top and bottom by 2. And 4 divided by 2 is 2, and then 18 divided by 2 is 9. So the probability of F given E, which is a conditional probability, is 2/9. And that's my second answer to the problem. Now I want to explain why one would expect the probability of F to change as it did when we added the condition that E occurred. If we look at our original probabilities, the probability of F was 4 out of 36, and then the probability of F given E was 4 out of 18. Notice that the denominators decreased by half. So the event E halves the number of possible outcomes, and it increases the probability. And that would be our explanation. You are to randomly pick one disc from a bag that contains the disc shown below. Find the probability of a star given yellow, or the probability of picking a disc with a star given that the disc is yellow. So this is another conditional probability, and we want to find the probability of selecting a star given that the disc is yellow. So the formula for this is the number of times that a star and a yellow disc appear, so that's the intersection, divided by the number of times yellow appears, which is our second event in our conditional probability. Okay, so for the numerator, we want to figure out the number of times a star and a yellow appear. So there's only one disc that has a star on it that is yellow, so the numerator is 1. The denominator is the number of discs that are yellow, so we have 1, 2, 3, 4 yellow discs, so the denominator is 4. That means that the conditional probability of picking a disc with a star, given that the disc is yellow, is 1/4, and that's our final answer.